Okay, I think we can start. Huh? There are a few invited people that are still missing, but there is time. Okay, so here we are at the 5th edition of the International Workshop on Marine Litter Monitor, Removal, and Circular Economy. It's a 5th edition means that we passed 5 years of this experience, a quite interesting experience in catalyzing innovation for exactly doing these things, to understand more about the problem of the marine litter. And most of it we know is about plastics, plastic pollution, and how to remove, so to try to find a remediation to the legacy of pollution that started about 70 years ago, in particular with the plastics, and how to make something out of this, how to prevent, in particular, the dispersal of litter in our nature, our environment, waters, oceans. This event is a part of the Missione Oceano and Waters, and there is an action of the Charter. But in addition to this event is also part of European Union projects, in particular Innovation Research Project, CCLEAR 2.0, Remedies, and we also have participation in other projects from ENFAF, and in particular, Interact project, JOINABLE. So why to do all this? Generally, we have meetings, project meetings, you know, but we wanted to catalyze people, communities, not just research or research institutes that are very important, but also representative of the society that have a stake about the environment, the state of our ocean and waters. And that's why we started 5 years ago with the CNR here to organize this event. Now, this project that we began with, the were Maestro Microplastics, they ended. But we want to continue, because what we started, I think, was valuable. And actually today, we want to thank the co-organizer of this activity, which is basically the Boat Show Venice. We start together. The Boat Show Venice started 5 years ago, so we start together. And SDI from Malta, and Vela, and all the technicians that made this possible. In addition to these, we have institutional welcoming greetings. In particular, we have the mayor of the municipality of Punat, is D.Strčić.
Thank you.
Thank you for coming, Daniel, from Croatia. And we have Elisabetta Balzi, who is an active senior advisor of the CDG Research Innovation. And J.Kolic, who is a journal project officer of IPA ADRION Joint Secretariat. Since it will be a very tight agenda and we'll finish about late lunch time, I would not dwell upon the introduction any longer, and I would like to give the floor to Elisabetta Balzi from Brussels.
Thank you very much, Davide. I hope you can hear me well. Good morning, ladies and gentlemen. Can you hear me, Davide? Can you confirm?
Yes, we can.
Absolutely, yeah.
Thank you. Good morning. So I'm really very, very pleased to be with you, even if, unfortunately, only at a distance. But I think your international workshop today is particularly important for our mission. You know, we have a European mission to restore our ocean and waters. The reduction of pollution is a main objective of our mission. And you have there, indeed, as Davide said, a particularly good configuration to contribute to this mission. So you have main projects from Horizon Europe. Davide mentioned Remedies, CCLEAR, the previous one like Maelstrom, have a project like Inspire, and you have Venice Lagoon Plastic Free, who has been, still is, a very important contributor to our mission through the projects, but also through a mission charter. And not only that, but what is very important that you have also representative, as Davide rightly said, representative of a broad range of stakeholders for our mission. You know that our mission is not just a research and innovation program. Of course, we are investing a lot through our research and innovation program, more than €500 million in the first 4 years. But the mission goes far beyond. The mission is a strategic mobilization initiative to involve stakeholders at large, to involve regions, cities, I'm very pleased that you have today, and I would like to congratulate particularly the mayor of Punat, and I would like to welcome you also in our mission. And you have regions, I think I've seen on the program regions like Marche region, very important also the participation of regions. We were also very pleased to welcome the participation, for example, of the Veneto region also to our mission with the recent addition to the charter. And so our mission is really a joint effort, and we need to work all together. What is also very important is that you have indeed also European projects which are not European Horizon Europe projects. They are part from other programs, and indeed they are equally important. They are very important for our mission. So we are working closely with other programs like Interreg, like MFAF, like LIFE, and of course with national programs, with regional programs. So really, this mission is a joint effort. David, I think you showed a nice video showing how important is the involvement and the engagement across our 4 lighthouses. Venice is certainly a lighthouse, has been inspiring and actions, and you are certainly at the forefront of this. And we are very grateful for all your activities. So we would like to encourage you. Many thanks for all what you're doing. We have, of course, many prospects and opportunities ahead. We also just opened new calls for proposals for the year 2025, so there are plenty of opportunities, and we are really looking forward to this joint effort. Many thanks to all, and let's keep on moving together for our mission. Thank you.
Thank you, Elisabetta. Thank you very much. Good. Thank you again, Elisabetta, for all the efforts you put in the Mission Ocean, really. And very inspiring, very inspiring. And I would like to give the floor to J.Kolic. So, if Jelena, are you there? Okay. Sorry. Okay, hope. Okay. All right, Jelena, are you there? I think J.Kolic, our project officer in Durable, she is connected. It's not working? Hello? Okay. Jelena, good morning. Are you connected?
Hear me?
Yes, now yes.
Perfect.
Hello, good morning.
Good morning to everyone, and thank you for your kind invitation to join you. In my case, unfortunately, also only virtually. And I'm representing Interreg IPA ADRION program, and I'm here today because the program is proud to finance the JOINABLE project that was mentioned, and actually this event is also part of the project activities, also with the Mission Ocean and Waters and some other projects that Davide mentioned. And actually this reflects the kind of collaboration that the program aims to support. And as the project will be presented later on, and we'll offer more details on its activities, now I would like just to take a moment to tell you about the program, IPA ADRION program, that is behind this project and the transnational cooperation. So our program, IPA ADRION, is a program that brings together 10 countries, both EU and non-EU countries, all working around common goals. And those goals in our program are regional innovation, environmental protection, and sustainable transport. But one of our strongest commitments is environment. And in fact, more than half of our budget goes to green priorities. And this actually reflects how the program is marked by strong sustainable approach, where green policy plays a major role. And within environmental protection, the circular economy became a specific objective for the first time in this funding period in response to growing challenges faced by our regions and participating countries. So now we are actually having the first generation of circular economy projects that are being implemented, JOINABLE one among them. And they are working on topics like blue circular economy or developing circular agri-food chains, promoting creative uses, or applying circular principles in public procurement and services. And also at our program, we are aware that these complex environmental challenges we are facing and that single region or actor can tackle them alone. And that's why we also place strong emphasis on creating synergies. Synergies between our program and broader EU or national initiatives, like already presented Mission Ocean and Waters, also Horizon Europe or Green Deal. And in fact, all teams and projects supported by our program are carefully chosen to align with all wider European priorities, so that each our project is part of a much bigger picture. And I think that today's event is a perfect example of that approach in practice by bringing together all these different actors, programs, and perspectives around this shared challenge. And I would also conclude by mentioning that this approach is also at the heart of our second call of proposals that is now open. So for all of you who are working in environmental topics, I think that, and I invite you to look into this call. It is open until the end of June, and it includes topics like climate adaptation strategies, protection of marine and freshwater ecosystems, sustainable water use, or pollution reduction. And also circular economy this time is not included as specific objective. Its principles still can be integrated in the activities that will be funded. So again, I invite all participants from the IPA ADRION program area to take a look at this open call and see where your ideas could fit. And I also hope that today's discussion will inspire some new connections and maybe new ideas that will be transformed into future projects. And again, thank you for having me here, and I look forward to following the rest of the program today.
Thank you very much, Elena. And I think this concept of bonding the mission, targets, and principle with the territories is the key element to make this program successful. So thank you very much for support from the Joint Secretariat to the mission. And Daniel, the floor is yours.
Thank you.
Introduce it.
Shall I go to the...
Oh, yeah, as you prefer. Yes, please.
Dear ladies and gentlemen, it's my great pleasure to be here today at the 5th International Workshop edition of Marine Litter Monitoring, Removal and Blue Circular Economy, and to have the opportunity on behalf of the project partners and as the lead partner to present the project JOINABLE, its joint approach to blue circular economy for the Adriatic and Ionian region, which is financed under the Interreg IPA ADRION program of the European Union. I usually don't prepare speeches, but for today I decided to write a short one that I would like to read to you. The project partners of the JOINABLE project are Venice Lagoon Plastic Free, Agency for Innovation in the Agri-Food and Fisheries sectors, Marce Agricoltura Pesca, both from Italy, Institute of Entrepreneurship Development from Greece, University of Montenegro Faculty of Maritime Studies from Montenegro, Environmental and Territorial Management Institute from Albania, University of Information Science and Technology St. Paul the Apostol from Ohrid from North Macedonia, Municipality of Divjaka from Albania, and two partners from Croatia, Sensum, and we as the lead partner, Municipality of Punat. We are all bonded to achieve the same goals under the European-driven policies in reduction of the marine litter pollution, to increase circularity and sustainable innovation in our economic system. In the Adrian region, there is a gap in the development of the blue circular economy related to waste originating from aquatic environments. Waste from marine and freshwater sources falls outside the jurisdiction of waste management companies and institutions and is therefore not included in the circular economy. The JOINABLE project aims to address this issue by integrating such waste into the blue circular economy. The goal is to establish and promote a blue circular economy by tackling the challenges related to marine and freshwater litter. Through the use of shared digital tools, monitoring and cleanup activities will be organized, and data on waste will be collected across different areas. Joint strategies and action plans for monitoring and removal of waste will be developed. An innovative value chain from waste to product will be also presented in this project. The transnational approach will enable effective knowledge sharing and adoption of innovative solutions. The innovative and novel aspect of the project lies in its pioneering approach to developing a blue circular economy. It aims to establish a framework for advancing the blue circular economy within cities and municipalities that have the potential for significant new investment. Total value of the project is 1.7 million euros, of which 1.46 million euros or 85% is co-financed by the European Union. Punat is a small touristic town on the island of Krk with around 2,000 residents. Each year we achieve approximately 600,000 overnight stays. We care deeply about environmental protection, not only we in Punat, but whole Krk has a few projects about environmental protection, and we separate about 60% of our waste. And for the past 28 years, we are organizing beach cleanup activities. Our beaches hold the blue flag certificate, and we regularly ensure the cleanliness and maintenance of all public areas, not just the beaches, but especially during the summer months, we are doing a lot on the beaches to make them clean and maintained. We are willing, as Municipality of Punat, we are willing to cooperate with other coastal towns, cities and communities, such as here in Venice. And thanks to the Interreg cooperation programs that represent an asset to bond people, communities and territories with shared goals and values. Another information is that we have registered the JOINABLE project under the Missione Oceano Charter, and the Municipality of Punat aims to become a smart city for plastic, following the example of Venice. And we also intend to join the charter as a signatory, just as the Veneto region has decided to do. Thank you all for your attention. I wish you a pleasant rest of the day and hope that in the long term we achieve as much success as possible in marine litter monitoring, removal, and the blue circular economy. Thank you.
Thank you. Thank you, Daniel, for your intervention, and thank you all for being here today. So my name is Manuel Scarpa. Today, I'd like to give you a warm welcome on behalf of ISDI and also of a WindBlue project, EMFA project that today we're going to discover with some of our speakers. This is the 5th edition, as you know, of this international workshop. We are glad to be back in this beautiful tower for of course, sharing with you the previous experiences of past projects, of course, the ambitions of the new ones. So it's now time to start. I'd like to invite the new speakers for the first panel here,
Absolutely,
the chair. And in order, I'd like to invite to join me here Maria Cristina Cocca, Andrea Camedda, Teresa Cecchi, and Corina Chocan. Thank you. Please.
would like just to introduce the first speaker. And she's a friend. She's a partner of a project called Remedies under the Missione Oceano Waters, and Maria Cristina Cocca. And you have a master's degree in chemistry. And you're senior researcher in the Institute of Polymers, Composite and Biomaterials of National Research Council of Italy. And your activity is focused on polymeric materials, micro-nanoplastic, and chemical physical characterization. And today you are talking about something which is a very urgent issue to tackle, which is microplastic release detection in the textile washing process. We know how much of the textile sector is polluting. And so we need to investigate further, what today, seriousness of the pollution, how to get rid of this pollution, prevent it. And this is the first session, which is about monitoring and assessing. Okay, thank you, Maria Cristina. The floor is yours.
Thank you, Davide. And I would like to thank, first of all, the organization committee of this very interesting international workshop. I will talk during this meeting about microplastic released from textiles, a topic on which my colleague and I from the Institute of Polymers, Composites and Biomaterials are getting ahead from at least 10 years. Just a few words about my institute. The Institute of Polymers, Composites and Biomaterials is the biggest Italian institute performing research activities in the field of polymeric materials and related technologies. We are located in different units across Italy. And our activities are mainly organized under the research area related to advanced materials that are realized and designed with the safe and sustainable approach, and also using advanced characterization techniques for the application in different sectors, among that the environment. In relation to the sustainability and the environment, we work for the realization of advanced materials to mitigate some problems due to pollutants or to extract natural substance to be used for the production of new materials, or like the realization of porous structural membranes for mitigation purpose, and of course the characterization, identification of microplastic pollution and their mitigation. Well, I start the core of my presentation illustrating a problem that is well known actually, but in 2017 the International Union for Conservation of Nature highlighted that the main source of microplastic pollution entering our oceans was the washing process of synthetic fabrics. While the microplastics of fibrous shape released during washing due to mechanical and chemical action on the textiles reach the water environment easily, since due to their shape and their size cannot be blocked by filtration system or wastewater treatment plants. And in fact, the occurrence was highlighted in everywhere. So in remote parts, like in the glacier, in the polar glaciers, or ingested in fish and shellfish at different level of the trophic chain. And considering that the production of polyester fabrics and synthetic fabrics dominates the synthetic fabrics market, we imagine that this problem will grow continuously in the next future. Well, since 2014, in the framework of Mermaids project, we started our activities related to this problem, and we developed some methods and procedures to evaluate and detect, identify and quantify the microplastics that are released during the washing process. And with this method, we started at lab scale and then we passed at real scale. We evaluated that the quantity of microplastic released from textile during the washing process is is enormous. So it was very huge. These methods allow us also to identify that the main factor that affect the release of microplastic during washing process and also during the usage, but also to highlight that in addition to microplastic, microfibers of natural origin like cellulose fibers or artificial fibers can be released and can constitute a problem for the environment, since they can be processed with some chemical substance or finishing treatments that could be transported in the environment. And of course, we evaluated also that the problems associated with the textiles substrates is underestimated, since not only garments are made by textile substrate, but different products that are used, and the release of microfibers can be obtained not only during washing, but also during the usage, the production, the disposal at the end of life. Here I summarize some of the main factors influencing the release that we have highlighted in our works. The first of all is the using of solid detergent that induce an improvement of the release of microplastics. And another important factor is the type of the structure of the fibers, since if we use fabrics made with yarns containing long and continuous filaments, they release lower amount of microplastic with respect of fibers made with short staple fibers. And of course, temperature, mechanical action of the washing machine could affect the release and induce an increase of the release of microplastics. Up to now, there is no standard procedure related to the identification of this type of pollutants in complex matrix or if ingested in the organism. And we can adopt different type of strategies, but we preferred to evaluate their presence by using their morphological features, since the analysis of morphological surface of this type of fibers can indicate if they are coming from natural sources or are of synthetic family. As a matter of fact, in this slide, I reported some micrographs obtained using scanning electron microscope or optical microscope, in which natural fibers like cotton or wool are clearly identifiable by their typical characteristic of their surface, while synthetic ones are more smooth, without surface roughness, and very, very regular along their diameter. And we used this approach to evaluate the presence of microfibers in tap water recovered in Slovenia. And we, in cooperation with an enterprise that was TF Lab, we used a filtration system that was allocated directly on the faucet in domestic, in different places in Slovenia. And we analyzed with the morphological approach the presence of more than 60% of microfibers, and in particular the majority was of natural origin, so there was a great contamination also due to presence of natural or artificial microfibers. And with the similar approach, we have evaluated also the presence of this type of pollutants in different gastrointestinal tracts of different fish taken from different depth of water column. This work was performed in cooperation with the University of Molise. And we highlighted that the fish that contained the majority of this type of pollutants was living in the deep sea, so sediments can work as sinks of this type of pollutants. And we also confirmed the chemical composition by using a spectroscopic approach with this in this work. In our institute, we are trying also to develop different solutions to try to mitigate these environmental problems. Among all the solutions and the strategy that we proposed, I will just illustrate the filtration system, the use of biodegradable polymers, and the recycling approach. So that are also actions that we are performing inside the Remedies project. In fact, inside the Remedies project, we try to develop filtration system to be applied to industrial washing machine in order to capture and reduce this environmental problem. And also at lab scale, we are working to develop new membrane able to capture these pollutants with changing the materials to have some biodegradable or sustainable materials. And in cooperation with the partners coming from Remedies project, we are developing formulation using biodegradable polymers and natural fibers to produce a new generation of fishing gear and to be used in sustainable way in the marine environment. And as concerning recycle approach, we are using plastic oceans coming recovered during cleanup activities to realize new materials starting from secondary raw materials, and so to add value to this waste. And here is an application in which we used the 3D printing to realize some object in the frame of Remedies project, starting from plastic recovered in the oceans. And in this one, we realized some protection from glass bottle using polyethylene waste recovered during cleaning up activities. And very important is to try to improve the awareness about these problems, and so we have engaging students to act as scientists and to try to evaluate directly the presence of this type of pollutants into the water, and also to improve the knowledge about the problems, but also on how to mitigate. And I conclude my presentation illustrating just our approach, that is to evaluate everything in order to have a complete framework of this type of pollutants, to try to develop mitigation fit for purpose in line with the environment and in line with the type of pollutants. Thank you.
Thank you so much. Christina, I think that there will be some time for question if we need up all time with the presentation, but it was very, 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 very good. And Andrea Camedda is also a partner of Remedies project, friend of partner. And actually, there were two Andreas from the same institute in Sardinia, and actually the CNR IAS. Andrea is marine biologist, he holds a PhD in ecology and management of biological resources, and you're a postdoc. Yeah, researchers and the CNR IAS, and basically because we came to visit your research center facilities, you're specialized in study of marine litter and interaction with marine organisms, and your main research topic is a study of feeding behavior of the loggerhead sea turtle, caretta caretta, that's what we know was called, the implication on the marine strategy. Okay, so Andrea, the floor is yours. And
well, thank you so much for inviting us, first of all. As you said, I'm here with my colleague Andrea, that is also the director, the coordinator of our team of research. Since we work in many different topics, above all for the conservation of protected species. Today I will talk to you about the sea turtles that we manage and we are studying from many years, and I will briefly describe you what is the situation in the Mediterranean Sea. I will describe which are our main topics of research above all, and toward the conservation of these protected species, as you will see. And you will see a lot of pictures. I hope I will be in time, but I will briefly describe our activity. So, starting from the species that we can find and we can study in the Mediterranean Sea, we have three main species: the green turtle, the loggerhead turtle, and the leatherback turtle. The loggerhead turtle is the most common and is our main topic of study, since frequents Sardinia. In general, around the world, this turtle frequents many different habitats, and for many reasons, as you can read, is at extinction risk, because also in Sardinia, we are describing a lot of impacts. We are located here, and you can see that Sardinia is located in the middle of the Mediterranean Sea, the Western Mediterranean Sea. So this is good information that we knew since a lot of years, that we are receiving turtles both from the Mediterranean Sea, but also from Atlantic. So Sardinia has an important role for the conservation of these specimen and these populations. In fact, we started to advise these problems for sea turtles since 25 years, because we found a lot of sea turtles injured and stranded along the coast. In fact, in the Mediterranean Sea, these are the three main impacts for loggered turtle caretta caretta: the accidental captures in fishing gears, the habitat degradation, that is a problem for the reduction of nesting areas, for example, and the pollution, so in particular the marine litter problem. For the mitigation of these impacts, we constituted a regional network, an institutional network made of all the protected areas and marine parks already spread around the coast. And we took this proposal from the RACSPA, the Regional Activity Center for Specially Protected Areas, with a proposal of a network of Mediterranean rescue and emergency centers. But our rescue center, the CRES, as you can see, is active from the 2000 for the rescue and recovery of sea turtles. This is the scheme and how we are organized in Sardinia. So we have a network, we have a very capillary control of all the coast, so we are able to rescue and to find, to collect all the turtles that arrive stranded along the coast. We are the coordinators as CNR of this network, the marine protected areas and the structure. We are organizing the rescue and emergency centers. We collaborate strictly with the regional body of Sardinia. This is a standardized procedure that is very important, from the signalization to the rehabilitation and hospitalization to the necropsy, sometimes with dead animals. But the very important thing is the release, because we have to give another try to sea turtles to survive. So we release all the individuals that we take care of. And this is it's a typical situation where we invite hundreds of people that come to visit our rescue center before the release. And so we are giving back the turtles to the wild. We are also, since we are also researchers, we are applying these instruments, or satellite tracking devices, to many individuals to track their routes. And look at this picture. You can see that one of the turtles that we released a few years ago trespassed the Gibraltar Strait and arrived to the Caribbean in less than 1 year. So after 5,000 kilometers, okay, the battery was stopped recording, but we have very important data. This is our rescue center. We organize in this way. We have a strict collaboration with the marine protected areas of Sinis. We have a veterinary center support, and we have the tanks where we hospitalize the sea turtles before the release. We work on the rescue and recovery, on the nest management, because Sardinia is becoming also a very important nesting area. And as Davide said before, I'm working on the feeding behavior and ecology of sea turtles. But during the collection of the fecal residual, above all, of sea turtles that after a few days start to expel a lot of organisms that they ate before, we are finding also a lot of plastic and marine litter in general, but plastic above all, both in alive and in dead animals. Also, the problem of entanglement, not only the ingestion, is a very important damage for them. As you can see, they remain trapped in sacks or ropes and so on. These are the effects, lethal and sublethal effects. So for the ingestion, they can have a blockage of the digestive tract, a lot of infection during the passing in the gastrointestinal tract, and also sublethal effects for the ecotoxicological problem, since plastic contains a lot of chemical. Taking advantage of the publication, the international publications that we have before, we constituted a group, a team of experts to develop a protocol, an experimental protocol on litter biota that has been approved and now is contained in the guidance of monitoring on marine litter in the European system. So all the Mediterranean countries adopt our protocol that we experiment in Italy for the first time to understand and to study the marine litter containing these organisms. This is the methodology. So, as I said before, we analyze the fecal pellets in live individuals that expel marine litter. We dissect dead ones, and we found also a lot of plastic in them. In lab analysis, we sort and we divide food from marine litter. We count and weight all the material, and we classify in categories. That is very important because in the protocol, we took the idea from the OSPAR convention, and we put this in the Marine Strategy Framework Directive guidelines. We participated to very important projects like INDICIT and INDICIT 2, and the important thing is that we constitute a very important network. In fact, once you can see on the right part, we were able also to recover a dead sea turtle tracked by our satellite in Tunisia. In reality, were 2 turtles, unfortunately. And since we had already this network, we were able to recover both the turtle, the dead turtle, and the satellite. In these years, in the past years, we developed and we had a lot of important publications on the marine litter and the interaction between marine litter and loggered turtles. We developed the indicator, loggered turtle, caretta, caretta. And we have here an example. I briefly described this, one of the last papers that we published about the polymer composition of ingested litter, because we try to go in deep on this problem. We collect animals from Sardinia and Lazio region. We analyzed the plastic ingested by all these organisms, and we found that the sheet plastic and the fragments were the most important, because sheets represent the plastic bags fragments that are very spread in the seas. But also the fragments were very important here. And so this important thing is that we use the FTIR, this instrument that is able to detect the polymer composition of plastic. We have a reference spectre to understand which is the polymer of these pieces that we are analyzing. We had both recognizable and unrecognizable objects or fragments, and so the FTIR was very, very important also to understand which was the composition of the unrecognizable pieces. Here in important subsample, we understand again that the plastic bags were the most ingested by sea turtles, and FTIR help us to detect which polymers really affect sea turtles. And if you see in the graphs, you see that polyethylene and polypropylene were the most ingested. Here in the study, we had a smaller frequency of occurrence, so a percentage of organisms that ingest the plastic, only the 40%. I say only because nowadays, we are still having a 90% of turtles in our rescue center that are ingesting plastic. And the important thing is that more than the 70% of PA and of polyethylene and polypropylene, was identified as single-use plastic. Single-use plastic that is the plastic that you use once and then you throw away. And so these are the most important. The log-rated turtle is effectively a macroliter sample, because remember that sea turtles used to eat macroplastics, so the visible one also for us, more than 2 centimeters, 2.5 centimeters, still more than 10 centimeters. And so it's a very good indicator for the plastic in general in the Mediterranean, for the pollution, but also a good indicator for the single-use plastic pollution in the Mediterranean Sea. It will be very important to extend this particular study around all the Mediterranean area that we already did, but we have to go in deep also for the polymer composition. And about the beach litter that represent what was in the sea, so what it was easy to be ingested by sea turtles, we did a study a few years ago about the beach litter characterization of micro and macroplastic, and we found the same objects. So, and it was a very important paper also as a baseline for the remedies project. So we used this paper also for the methodology that we are still using for the monitoring of the beaches. Thank you so very much.
Thank you very much. I mean, it's quite interesting to see, because, I mean, a researcher can research and say, okay, because the investigation is something that you do because you are talented in doing this, because your profession, but actually the interface between science and policy is extremely important. So we have reliable data we can go, and also as an NGO to advocate. So we are linked each other, okay? So research center, civil society, to go to the policymakers or decision makers and say, we need to change something here. The system production, the single-use plastic directive was, I think, originated because there were solid ground, scientific ground to make this happen. And we need to keep the pace. And so there's so much to do yet. So we're just at the beginning of facing this scourge.
Yeah, if you want to work on the conservation of these protected species, we have to combine both research and policy. So it's
absolutely
perfect.
Sometimes politicians don't want to listen.
But we
although they have all full evidence, they say that it's not true. But actually, we will repeat and we repeat every time again and again, and hopefully get in the head. Not all politicians, by the way. All right, so we have two speakers. We're talking about an emerging issue here. It's about the end-of-life boats. It's about fiberglass and pollution coming out of this source of pollution that we generally don't think of, but actually it's something that we need to take into account. And so I would like to give a floor of Professor Teresa Cecchi, first, who is Teresa, you have a master's degree in chemistry and PhD in analytical chemistry, and you're author of many scripts, books, and monographies, and peer-reviewed. Actually, I can tell you that she writes like a mad and a good sense. And so Teresa does a lot of things, so we cannot list all of them, but among those, forgive me if I can't, but she serves as the associate editor of the Journal of Liquid Chromatography and Related Techniques, and deeply involved in didactic research. She's a member of the Academy of Science Bologna and a member of the Directive Council of the Italian Chemical Society Didactic Division. So, and now you're going to present the chemical fingerprints of the end-of-life boat in Venice.
Okay. I thank the organizers for this kind invitation, for having me here, for sure. And, okay. Okay, so we will discuss a pristine research area that is the chemical fingerprint of what is leached, what is released from the end-of-life boats here in Venice. Okay, so let's dive right into the sampling location. Sacagnana Canal is quite remote, far from the heart of Venice. Here you see the heart of Venice, where these luxury boats are alive. And in Sacagnana Canal, they are dead. And I thank the Venice Lagoon plastic-free operators for sampling in triplicate mud, water, and soil. And I was provided with these samples. And here you see the lab where the analyses were carried out. Here you see a gas chromatograph hyphenated to a mass spectrometer, and on the top you see a robot for the pre-analytical workflow. And well, I would like to stress that this is a pristine research field and the first assessment of the chemical leaching. Also for policymakers, this is important for sure. So it's a pioneering work. And let's have a look. Oh, just a moment. The chromatograph is a kind of instrument where you have your molecule, you give the possibility to the molecules to run in a kind of road that we call column. So you inject them and they are captured for longer or shorter time by a stationary phase while they're pushed towards the detector. So sooner or later they will arrive, but not together. So they get separated. And this is important. What we record is the chromatograms. We have 3 representative chromatograms of water, soil, and mud, and we were able to identify 43 analytes, and interestingly, 15 of them are related to polymer chemistries, and you will see highlighted in yellow the peaks. Each peak is a molecule. The peaks, the molecules which are related to polyurethane. And we can see that in the chromatogram, each peak is one analyte. And please don't be scared by this kind of tapestry of chemicals. We don't have time to deal with all of them, but from raw data, we need to extract some knowledge. And we have to perform some educated guesses about the origin of these molecules. Most of them comes from the anthropic activity, but interestingly, many of them comes from the biotic environment, for sure. For example, ketone that comes from chlorophyll. But many of them come from the construction materials, fiberglass, reinforced plastics, polyurethane, foams, and coatings. So let's focus only on 6 of them. They are number 2 and number 3 are the 2 building blocks of polyurethane. They are butan diol and the toluene diisocyanate. Number 2 and 3. You will see that number 1 and number 6 comes from number 2 because number 2 can be closed as a cycle, and if you close 3 of number 2, you get number 6. And number 5 is a degradation product of number 3 because of hydrolysis, and water for sure is not lacking in the lagoon. And number 4 comes from the resin, acrylate resin, polyurethane acrylate resin. According to the European labeling regulation, you will see that number 1, number 2, and number 5 are suspected of causing cancer, so they pose a serious concern about health. And number 5 is also dangerous for waters, for the marine environment. And the signal words are worrisome, for sure. And how can we be sure that they are actually these molecules? Because when the molecules come out of the detector, of the column, they are shot by an electronic gun, high energetic electrons, so they break down, and we gather the fragments to get the mass spectrum over here. Down there you have the library mass spectrum. You can also visually see that the match is perfect, so the molecule is identified. And then we don't have perhaps time to go in more depth, but I'm open to discuss later, perhaps, because this is an exciting research field. But we have also molecules from common chemicals and pharmaceuticals and fossil fuels. We got these results with Dr. Poletto published last March, but we previously previously studied water from the heart of Venice. So 5 years ago, just a few months before and a few months later than the pandemic lockdown, we can now compare the results from 5 years ago and now in two different places. What is stunning is that in the middle, in the center of Venice, we don't find polyurethane-related molecules. So this means that this demonstrates that they come out when the boats are abandoned and left to the weathering. And then we go to the conclusion. I'm a teacher, and I try to inspire my students with sustainability goals, and via a kind of research-oriented teaching and project-based learning. So what we did is not to follow a standard operating procedure, but to devise, to plan, to organize, and to carry out a green procedure in order not to pollute while analyzing pollutants, for sure. And the claim of the greenness comes from two metrics that are the AGREE and the analytical eco scale. The only red flag is the fact that we cannot perform in situ analysis, because we need this kind of instrument to perform the analysis, for sure. But above 0.75, the procedure is considered green, and so these are our figures of merit. We did it in a completely solventless way. We use a solid phase microextraction with a fiber that is able to absorb analytes from the sample. We retract the fiber inside the needle, and we inject the needle into the instrument. Actually, a robot can do this for us in a very accurate way. We only program the robot. And we go to the conclusion. I need to stress that ghost boats, we know, release scraps, microplastics, fiberglass, but it's time to think about the hitchhiking of pollutants and the leaching of pollutants from the ghost boats. And so I thank you for your attention, and I'm open to discuss.
Thank you, Teresa. So one of the many innovations of Teresa, actually, and that will be involved on the field on many different activities, and where other things ongoing with the microplastics and contaminants in the laguna and the seaside. So we will start a new campaign this fall, and so we'll see the results after that. But it's very interesting to notice that, you know, the polyurethane come from the boat that you could even see before. There were a couple of boats like that with polyurethane inside, broken, and probably there were boats from the 70s, okay? So nobody take care of them. I will have a presentation later on about the regulatory problems in the European Union, why this happens, and so especially for recreational boats. But Professor Corina Ciocca will also tell us something about the UK, because we have the same problem. And so Corina Ciocca is a principal lecturer in marine biology, University of Brighton. So thank you for coming from UK. Thank you. And expertise in ecotoxicology, focusing on biological responses of marine organisms to environmental stressors. Okay, and so basically you have developed a strong interest in glass reinforced plastic, so GRP boats, and their impact on the coastal environment. And you have published research, you have impact on this, and also TV, and so you are also advocating for this.
Yes.
So, Corina, the floor is yours.
It's this one.
Yeah.
It's coming. Oh, sorry. Need to be patient.
brilliant, lovely. Thank you. Thank you very much for having me. I kind of feel a bit of an outsider, you know, outside EU, Brexit and all that. But fortunately or unfortunately, there are no boundaries in the ocean. So one way or another, you know, our pollution is your pollution and the other way around. So I'm an ecotoxicologist. I know it's a mouthful, but what I'm interested in is the health of those animals. I had a very convoluted career. I graduated from biology, and I'm saying this for the students, if there are any in the room. Your career is not going to be a straight line. Yeah. So I graduated from biology. I have a master in biomedical. And then I did a PhD in veterinary medicine. So I'm a true doctor for fish and shellfish. So that's what I care about. I care about the impact of stressors in the environment on those organisms. And unfortunately, this is a never-ending story. And, well, maybe fortunately, because that keeps me in the business. But we discover every day that more and more stressors are detected in the environment, as Teresa was saying, and that's me coming after and trying to see, right, polyurethane, what is that going to do to my oysters? How is that going to affect the survival, the reproduction, the life of those animals? So I'm going to go very quickly through this because I'm sure Davide is going to talk about this a lot. In my presentation, I have a couple of highlights. First, the boats. This is the latest stressor that I discovered, you know, with all their pluses, you know, their successes, yes. GRP boats, very, you know, the material, it's wonder material, and the boat is going to survive for years and years. They're light, they're very quick to mold, to manufacture, cheap, debatable. Anyway, we've got thousands of marinas, hundreds of thousands, if not millions of boats. This wonder material that actually has been first developed 100 years ago, almost, as the material for coffins in New York, because it was supposed to last. That means that those boats are going to last as well. The industry is booming, as the guys outside are going to tell you, probably, because that's why they're very nice dressed and shiny in their little booths over there, trying to sell yet another yacht. Yeah, the industry is going to quadruple in the next 6-7 years. And what's going to happen at the end? We're not in the position to have a solution for everything for the end-of-life boats. I'm sure Davide is going to talk more about this. This is a very tiny boat in Chichester Harbour that is very close to my university. Left to rot over there with a handheld microscope that nowadays is my tool of choice. It's only about 20 euros on Amazon. So all my students have this when they go scouting for all boats now. You can see the fibers, and those fibers are going to be, you know, taken by the wind. They're going to pollute the air. They're going to pollute the sediment. They're going to go into the waterways, and they're going to be accessible for anything from crabs to oysters to clams to you name it. And obviously, that was one single boat in a very posh, if you want, very wealthy harbour in the UK, where we have residents from, you know, Rolling Stones, for example. The guys from Rolling Stones live there. But what happens here? With all the fibres that are going to be exposed, and they're going to be taken by the wind, and they're going to be carried in the water, accessible for all the animals. I had a chat a few years ago with the Prime Minister of Vanuatu, who was telling me that, you know, after a typhoon, they were left with 20,000 boats destroyed. Nobody came back to claim them, obviously. And so that tiny island had to deal with 20,000 boats. Only 2 boats taken to the landfill on that island would have completely shut down the landfill. So that's a major problem that it's not only in Venice, not only in the UK, it's, you know, a huge, huge problem. I like that diagram in the corner that is telling you how many hazards are on a boat or an abandoned boat. That is another picture from Chichester Harbour where the old boats are crushed and taken to the landfill. That's not going to happen because, again, we're an island, probably a little bit bigger than yours, but still an island, and the landfill is limited and the regulations are very strict. So all those boats, they will have to go somewhere. And my role is to look after the animals and to understand what all those bits that are coming out, starting with the chemicals that Teresa was talking about, down to the plastic and down to the fiberglass, what are those going to do with, in the environment? And it's very interesting because I heard earlier Maria Cristina talking about how the fibers are considered the main component of the plastic pollution in the environment. I think the boating industry is the main culprit here. There are studies that are showing that in the North Sea, 80% of microplastic pollution is actually coming from the boats. Paint that is applied on the boat is 50% plastic. And that paint is fading away in normal life of the boat. It doesn't have to be an abandoned boat. That plastic is going to come out and pollute our waters. What I'm interested in is that fiber, that glass fiber. So that is a microscope magnification of the GRP, the glass reinforced fiber, where you can see the bits of plastic, phthalate. I think that phthalate was mentioned before, and that is the glass. So that glass is the one that I'm going to go past this, because I'm sure David is going to tell you more about. That glass is the one that I've identified in Chichester Harbour, as I said, quite a wealthy neighbourhood in south of France, no, I wish, south of England. We collected samples from soil, animals, end up in a pub, obviously, as you do. But what we discovered was absolutely staggering. We discovered those tiny bits of glass in oysters and in mussels, up to 7,000 pieces per kilogram. So next time when you have your moule marinière, 1 kilo will bring a few thousands of fiberglass as well. And it was absolutely mind-blowing, and we realized that the most concentration, most number of fibers we'll get was in January. Not random, because that was the time when the boats were actually on the dry dock. They were polished, they were cut, they were repaired, and so on. So a lot of fiberglass in the air, a lot of fiberglass in the water, and then the concentration went down a little bit during the year. We did all the chemistry to make sure that, yeah, this is glass, E-type glass, exactly the one that is included in GRP. The plastic was phthalate, which again, big red sign. Phthalate, a big group of chemicals that are involved in endocrine disruption, anything from reproductive impairment to brain development and so on. What is really tricky and annoying about this GRP is that when it's cut, that cloud that results from cutting or scraping has two components here, the plastic component and the glass component. Once that cloud gets, that powder gets in the water, you can clearly see that the plastic will stay on top and the glass is going to go down in the bottom. And from my point of view as an ecotoxicologist, this is kind of a contamination bomb. You're going to have all the animals that live in the water column, and especially at the top, you know, the zooplankton, the larvae, the fish eggs, and so on, even the birds that are going to be attracted, contaminated, ingesting that material. And then, as you see, this is Daphnia, this is the water flea. It's a very, very cute organism. It's a crustacean, very tiny, and it represents the food for hundreds, thousands of other species. And apparently new research into this animal shows that actually it's quite intelligent. Here you have a Daphnia that is playing with a volvox. A volvox is a tiny algae, microalgae, and you can actually see in the video that it's playing. It enjoys being around this tiny algae. So it's not just, you know, a tiny microscopic organism. It's an organism in itself that needs to be protected. And that is a fiberglass. And that is a tail of a Daphnia, and that is a head of a Daphnia, and they're both basically covered in that particles, in plastic particles that are coming from the GRP, because there is this electrostatic attraction between the organism and the plastic, but also the organism has this scale exoskeleton that will attach where the plastic is going to be attached and is not going to go away. 90 minutes, so an hour and a half, 2,000 Daphnias in the small jar, 3 grams of fiberglass dust, all Daphnias dead. 90 minutes. That's all it took for all the plastic to cover the animals, sink them, no possibility to swim or to come back to the top, absolutely everything dead. It wasn't my intention to do that. It was a one-off experiment because obviously I wouldn't be allowed to kill organisms just to prove a point. That would be crazy. But that's what happened. Which one do I still have? There you go. Yeah, so we did a lot of research on the different pieces of old plastic. We brought them to the lab. We put them in tanks of water, under light, waves, different temperatures, you know, the whole gimmicks that we scientists do usually in the lab. And we realized that they are going to release a lot of polyester, a lot of silicate fibers, a lot of particulate material able to be quantified, able to contaminate and to be spread, and then obviously able to be ingested by the organism. On top of that, the interesting thing is that we discovered fiberglass in a lot of other bits in the water. And in the middle over there you have a small snail that has been impaled by fiberglass. Here you have pieces of algae. That's another snail in the corner over there that have been impaled. So it's a little bit, imagine like a huge javelin being impaled in humans. That's kind of the ratio, and that's kind of the scale of the process that is happening in the water. Those fiberglass, in my papers, I always refer to them as asbestos-like fibers, because they have the exact characteristics of asbestos. They are natural fibers, the glass. 100 years from now, glass is still going to be glass, yeah? So it's not going to be degraded in anything else. And they are so small and so fine that once entering the organism, they're not going to go out. With the microplastic pollution, we approximate that mussels, for example, if you take mussels and you put them in a clean environment, they might be able to eliminate about 80% of microplastic. With the glass, they're never going to do that. And that is the danger of asbestos, for example, because once it enters your organism, your lungs, they act like splinters. So they're going to get into the tissue and they're not going to get out. And that's exactly what's happening with my animals. I keep saying my animals, they're not mine, but I take care of them. Right, I'll try to go a bit faster. Yeah. So again, this is not a UK problem, this is not a Venice problem. We recently published a paper where we showed that lovely Rachel Kozlowski, she went to Cambodia and she found huge quantities of fiberglass over there. So it's the fact that we don't know about it is just we never looked for it, yes, but my idea is that it's everywhere, and once we start digging a little bit more, we're going to find something that we might not be too happy about. In the UK, there is a little bit of a taboo subject, this boat abandonment, because obviously, like everywhere, I suppose, there is a lack of registration and there is a resistance when it comes to the registration of the boats. Remember that England is the country where we don't have an identity card. People don't want to be identified necessarily. So registration on boats, it's absolutely crazy. The thing that I want to demonstrate through my research is that those boats, those abandoned boats, are hazard. I just had a discussion this morning with a colleague in Sydney Harbour in Australia, and he was telling me that it is absolutely mind-blowing how people can abandon their boats. Imagine if they would abandon the cars, if they would go on the street and just dump the cars and then would go. I wanted to make that my big introduction here, and then I realized that this is Venice, you have no cars, so that wouldn't be, you know, a big revelation for you, but this is exactly the point. People can't abandon their cars, they have registration, and then there is a little bit of something else. The cars are considered a hazard, and the hazard comes mainly from the fact that that little catalyzer, I'm an expert now, that little catalyzer in the engine contains asbestos. And that has to be manipulated only by specialists. And therefore, if you leave the car and abandon the car on the street, it's considered that you put other people in danger because that asbestos can leak in the environment and la la la. If we manage to demonstrate that those abandoned boats are hazard, not rubbish, because that's what they consider now. They consider rubbish. If you drop your rubbish on the street, nobody's going to punish you, is it? Maybe some neighbors are going to shout at you or something, but the authorities are not going to follow you. But if you leave a hazard on the street, then you're going to be punished or you are going to be forced to take care of it. So that is my pledge now, to demonstrate that those abandoned boats are actually hazards. A hazard because of the chemicals that they leak in the environment, a hazard because of the fiberglass that they leak in the environment. And then the whole story is going to change. And then the authorities are going to start listening. So thank you very much for having me. I hope I didn't shock you very well, very much.
Yeah, well, you need to shock us, because we need to be woken up, because we're walking, sleeping. And that's, the other thing is very important, and I used to say that, especially when we investigate, we study, we are more and more aware, there is a research object, but then you see not just a research object, you see there is an animal, there is a life to protect, to save, and this is the degree of empathy that we need to have within ourselves in order to save ourselves on the planet. There is no science, there is no policy if we are not empathic people. And I think this is open other chapters of social pathology that we are facing nowadays. And what we're seeing now happening, the social environmental transformation change around us toward the climate, but not only degradation, and it's coming from there. It's coming from there, from wrong paradigm, from wrong ways of thinking, but also the incapacity to feel, to perceive something that's beyond our ordinary horizon. So be human means to feel human and to behave like humans. Okay, sorry for this, it was very touching. And if you don't mind, I know that we're on a bit, okay, we're a bit late, but I would like to spend 2 minutes break to fix a few technical things and to resume as soon as possible. But in the meanwhile, I would like to give the floor to whoever is connected here, physically or on the web, if there are any questions to our speakers, and just a time for question and answers. And then we will have a pause of 3 minutes, and okay. Please, feel free to address our guests. Maybe we can talk after, during the lunch break.
They are shocked.
Yeah?
People is shocked.
People, yeah, I think we got, yes, speechless. Oh, yeah, yes, please.
More or less in the latest years related to the marine environment, since I'm a technical staff, but these biological and chemical informations were more or less more important for myself as a mom, as a pupil, as a citizen in the coastal area. So when you talked about our food and something which we are ingesting and consuming day by day, surely we, as Davide said before, we should think about the species, other species, and we talked a lot today about it, and about the empathy. Perhaps the new generations and ourselves, we are still more selfish. We should be aware of the impact on human health much more than it could be an important glance for the raising awareness to the wider public and the authorities, for instance. So if they are not so into the other species, perhaps they should understand it better if you are talking about themselves and those like the highly developed species of this planet. So this is like more or less than like a comment, but nevertheless the presentations were more than wow for myself, since these were very practical part of the science. So regards to all of you, and it was very nice.
Thank you very much.
And you're absolutely right. I think one slide that I actually jumped over was a slide to present one-of-a-kind experiment in the UK. The Welsh government, so in Wales, the Welsh government awarded £5 million about 2 years ago for a small project to identify abandoned boats in D estuary, an estuary in Wales. Why did they do that? Because the fishermen in the estuary were worried about the abandoned boats in the location where there were a lot of clams, and clams are the main. The Welsh people eat clams for breakfast, yeah? So that was the national dish, and they were very worried about it. So it's a worry about, you know, the health of the humans, worry about the business as well. So you're right, we have to emphasize, you know, the impact on things that worry us the most. By the way, that £5 million project only finished. Davide, you were last year at the conference, and it was we had a presentation over there. They managed, with £5 million, they managed to identify about 60 abandoned boats in only 3 locations in the estuary. They hired, you know, divers and people to go and look at the condition of the boat and so on. They managed to get out rubbish around the boats, because once you abandon a boat, that becomes a dump, and next day you'll find a fridge, freezer, and then a mattress, and then God knows what next to the boat. And they actually approximated that each boat would be to rescue, to take the boat out, cut it, crush it, and take it to the landfill. Each boat would be somewhere between 20,000 and 100,000 pounds each. And they identified 66 boats in 3 locations. So it's absolutely mind-blowing. And then you go out and you see the price of a new one, and you think, is that fair? Is that fair? No.
Yeah, true.
But there you go. Thank you.
We will talk more about that later. So the discussion will go on. Thank you. Thank you very much. Okay, so just a break at 3 minutes. Okay. And thank you very much. All the speakers. Super, super. Grazie, grazie. Okay. Ladies and gentlemen, we're about to start. Thank you. Okay. Okay. Nicola, come here, please. Alex. Jana? Matteo is online. Okay, so we get into the second part of the program, which is about the marine litter cleanup solution and demonstration of these solutions. So we need also to think how to get rid of these plastics or whatever contaminants we may find. And so the first speaker is online. He's a colleague, he's Matteo Smith. Matteo Smith is a representative of the Hamburg Port Authority and is a partner of the European project Sea Clear 2.0 of the Missione Oceano waters. So Matteo holds a master's degree in international relations and research master in international studies and a double degree bachelor's in international business administration from Germany and Colombia. And has worked as EU funding consultancy based in Brussels and various research consulting positions. And he is currently working as a project manager of Sea Clear 2.0, okay, the project just mentioned. So, Matteo, you're just fresh from the Hamburg test of the Sea Clear 2.0. Maybe you may give us some glance of that. And the floor is yours. Thank you, Matteo, for joining us.
Thanks, Davide. Thanks for the introduction as well. And sorry for not being able to be in person with you, but thanks for facilitating this online connection, let's say. As Davide said, I want to tell you a bit more about the Sea Clear 2.0 project and also the Hamburg test that we just did last week, actually. Quickly to confirm, I brought some slides. I'm not sure if you can see them already, or should I share them with you?
They will be displayed, honestly. They will be displayed, Matteo, so.
Okay, perfect. So, as I'm not seeing them in parallel, I will just look at my own slides. Basically, on the first slide, you will see some project information. So let me, yes, perfect. So let me quickly introduce you into the project, explain you what we do. So basically, Sea Clear 2.0, as it says there, has the title of Scalable Full Cycle Marine Litter Remediation in the Mediterranean, Robotic and Participatory Solutions. So that means that Sea Clear 2.0 as a project focuses on looking into marine litter and reducing marine litter in especially the Mediterranean, but also other European seas, as for example, as I'm coming from Hamburg, the North Sea and other regions. What we do is we develop a system of robots, of autonomous robots and drones that aim to monitor, to detect, and then to collect marine litter, especially from the seafloor, but also from the surface. And as we just heard about microplastics and so on in the presentation before, there's also a lot of plastic and other litter that is not seen, and it is on the seafloor. So this is more than 90% of the litter that we have in our oceans and in our waters. So we're not even aware of these big problems. Maybe some of you are scuba divers or have snorkeled, then you might also be familiar with seeing plastic bags, ghost nets, and similar things on the seafloor. But basically, this is the focus of our project. We kicked off in January 2023, and now we're kind of 2.5 years into the project with a consortium of 13 partners from 9 different European countries. So really a very European-wide consortium to tackle different regions and areas as well. And basically, this is the focus of our project. But today I want to focus more on the Hamburg pilot that we did. And on the next slide, you will see basically the objective. So a pilot or a demonstration of our system means that as we have these different partners in different regions of Europe, each partner develops their own component of our whole system. And then, of course, we need to bring all these components together to test them in real life environments, because it always changes, conditions change when you come from the lab into real environments. You may know that, but especially because we have that from different partners, we need to bring them all together. So just last week, what we did is the first demonstration of our Cyclic 2.0 system. And therefore, all partners came together. And the aim was to demonstrate the effectiveness of the system, but also to test what technical, logistical, and legal requirements we have. Because we're talking about autonomous robots, autonomous systems, and therefore there are certain legal requirements. For example, you need a permit to actually perform autonomous missions or routes on water that is accessible by other people as well. And then, of course, we want to validate the system, this development of the system that we're in, but also the functionality. We want to then, of course, find, detect, and collect some real marine litter to showcase that the system is working and that it is an effective system, an efficient system to tackle seafloor marine litter pollution. And as we have 6 different demo and pilot sites, we also aim to kind of be a reference point for a potential worldwide or European-wide application. And therefore, we started in Hamburg. We have different sites afterwards in Marseille, in Cyprus, in Dubrovnik, also in Venice and in Tarragona, Spain. And basically, we're looking into different environments. You may imagine that here in Hamburg, if you've been here or you have been to the North Sea, you don't have the same visibility as we have in the Mediterranean. There's no turquoise waters with many meters of sight. 50 centimeters of sight is often already very much and very optimistic. So basically, that's also kind of the idea of having these different sites to have different environments. To start with, on the next slide, to start with such a demonstration, you need, of course, kind of preparations and a test site. So you can imagine that we built up such a test site. On the right side, in the right picture, you can see what we built up. So basically, this is in the port of Hamburg, one of the operational ports sites of the HPA, the Hamburg Port Authority. And here what we did is we went into the real environment. So we looked into a water basin that has real pollution because there's industrial movement. There has been industrial movement for many, many years. So you could imagine that tires, iron bars, and many similar industrial litter objects are in the water without even being conscious about that and without knowing that, because the visibility is that bad that you couldn't see, even if the water is only 3, 4, 5 meters deep, you don't see that. So we found this place, and then we built up this test site where you can see all these tents built up. Underneath the tents, we have many, many tables with all the laptops, screens, and monitors that you could imagine. We have like 20 to 30 people working there every day, all their interesting and very detailed programming and system software development and debugging and things like that. And then you can also see here in the picture some of the boats that we have. For example, the yellow boat there. This is the Sea Cat, kind of the basis of the aerial drone, of the underwater drone, and so on. On the left side, you can also see a picture where, with a different view, where the spectators that we invited had a view on some monitors with very detailed technical information, but also a view onto the water. Then this is just to give you an idea how this looks in practice, let's say. But on the next slide, I want to explain or show you a bit of the challenges. As I already mentioned, lab conditions are always different. So In our case, Hamburg is not famous for its great weather, but we were very lucky with the sunny days. But then actually on the most important day, or the most important day in terms of public visibility, when we invited some media people and so on, we had wind with up to 80 kilometers per hour. And on one side, the tents wanted to fly away, but the drones didn't fly. So this was kind of the challenge that we experienced in that demonstration. Of course, the drones, you might now ask, like, why don't they fly? The professional drones, some of them could also fly with this wind, but then you have another legal component, because you're only allowed to fly if your drone is insured, and insurance policies usually regulate the maximum wind velocity, and this is way below 80 kilometers per hour. So these are things that you only get to learn in these real-life demonstrations, and that we weren't that much aware about when we planned and when you go into the project, and then you have to calculate that maybe technically you could do that because your drones are able to fly with 80 kilometers per hour, but then you also have to consider the legal framework. Then one thing that is very particular in Hamburg is that we have heavy sediment. So basically when we went for one of the tires, for example, and wanted to grab it, it was kind of close, and then it was filled with sediment and some iron bars on top of it. And that is something that in the Mediterranean might be different because you have sand and so on. In Hamburg, you have very heavy sediment that increases the weight of the objects and therefore also increases the difficulty to grab these objects. Then, as I already mentioned, visibility. Here I brought you on the right side, well, you see this picture of the sonar image. Not sure if all of you have seen sonar images before. Basically, you use, or we use sonar when camera images don't really work because visibility is not good enough. This is just a different technology to see objects in waters of
couple of minutes because we are running out of time.
Yes, no problem.
Sorry.
And basically, you can see here we mark this grapple fingers and also the tire being grasped. You see that it's difficult to detect these things underwater, even when you know what you have there. Then, well, a stage of autonomy. This is, of course, something which is a process to develop, and some software interfaces. But let me show you just a few more slides. On the next slide, you see this achievement. So basically, we were able, in our first demonstration, to do some autonomous litter collection already. So you see on the right side, these surface litter collection vehicles. They are fully autonomous. They have their own mission. They can drive their own way around litter objects and collect them. And we also successfully grasped a litter item, which I will show you in a minute. And then you could also imagine that, for example, on the left side, you see this yellow boat with the grapple, and you see the kind of orange tender boat next to it, where the litter items are dropped to bring them back to shore. And therefore, they have to dock, and this is also an autonomous process. Well, looking at the time, just one more slide, and then I have a short video for you. So here, just a few ideas of how we connected the technical tests with some media that came there, and also some stakeholders that we invited just to raise awareness, to make it more public, to talk to potential end users, to potential clients that might buy the system in the future, to then hopefully tackle more seafloor litter with our system. But on the next slide, I have a video. I hope that this video works to play. And this is basically a video from one of the television channels that were present, and that kind of made a 2-minute video of the whole demonstration with some nice videos showing how the grapple.
Did you send it out to us? Sorry, did you send this out to us? This video?
This is it should be integrated into the presentation. So
okay, because I was thinking, in case we can show it afterwards, What do you think? We will,
Sure.
for sure, we will display it, but better afterwards so we can move forward.
No problem, no problem.
Okay.
So yeah, I can also share the link again with you. So maybe you can show it afterwards. If not, you can
Yes,
have a look.
please send the link on the chat.
Home, but
So we have it.
yeah,
Thank you.
of course.
And
Yeah, basically there you will have just a better idea of the whole system in action, as this yeah, shows some videos of all the different system components. Basically with that, on the next slide, I'm just wrapping up kind of what the next steps of our project are. Of course, there's always some debugging to do when you have technical developments and a lot of software. And
yeah, and
then we want to further develop our AI.
Next year, we will come here during the boat show. We will display the CCAT, all the, part of the technologies in this venue. So this is what is upcoming. So that's good that you test in Hamburg, so they will be better performing here.
Exactly.
And thank you,
We'll do a lot of debugging and further development.
Yeah, the bug.
Perfectly working in Venice.
It's imperative to debug. Okay, so thank you very much, Matteo. Sorry for running out of time, unfortunately. And thank you for linking. We will stay in touch very soon.
Perfect.
Soon,
Thanks for the invitation.
Thank you, Matteo. Thank you very much. Bye-bye.
Bye-bye.
Okay, so the next speaker is Nicola Rubini. He is from Mold. Actually, he's a partner of Remedies project. And Nicola holds a master's degree in international business for the University of Venice, in addition to 2 masters, on marketing communication. Yes, exactly. And so you, since 2020, you're involved in the river cleaning project, working primarily in the marketing, business development, investor relations, and fundraising. Everything. Yeah, that's just. Yes. His goal is to spark a revolution in river remediation with a particular focus on reducing plastic pollution. And as a member of the river cleaning team and contributor to the Missione Oceano initiative, he also mentored European level organization and startups, helping them assess the marketability of the innovation. So his contribution today is fighting plastic litter in the Lana River in Tirana with the river cleaning action. The floor is yours.
Thank you, Davide. So just thank you for having us today, and thank you also for organizing this conference. It's always good to participate every year. Just a word for everyone that doesn't know us, River Cleaning Team. We're a small, medium enterprise based in Vicenza. And basically what we do is we design and make solutions to clean waters in rivers. So that's our target, and that's what I will show you today with this small presentation. How does this relate to the Remedies project? Well, our demo site, which we have some representatives here today as well, is located in Tirana. And why is that? Well, the visualization is a little bit changed from the last time I uploaded it, but no worries. How do we select the Tirana demo site? Well, first of all, Remedies is an, let's say, very comprehensive project that tests innovative solutions that have a direct impact in the Mediterranean Sea basin, and does that through 3 main pillars. So one is, of course, detection and monitoring, one is collection and valorization, and one is prevention and zero waste. And as a collection technology, we of course focus on the collection part. Why did we choose Lana River? Well, first of all, because we know that rivers that flow through the Albanian country to the Adriatic Sea are significantly contributing to pollution in the Adriatic Sea. And we also saw that the region of Tirana, but not only, Albania as a country, has an increasing attention and implementation of policies towards waste reduction and environment restoration that happen to the, let's say, area of Lana River as well. And of course, Tirana is a fairly big city, it's the capital, and they have a fairly large population. Why do we operate in that environment? Well, I just wanted to remind you that basically every year we have 8 million tons of plastic which are dumped into our rivers, but just a tiny fraction of that material just ends in the sea in the very same year. So that means that we have a lot of material, like 6.5 million tons, that are circulating within our river basins. It means that they're moving from point A to point B in the same river, maybe changing rivers, like from tributaries to bigger rivers, and it's staying there for a lot of time. And what does this litter? Of course, it breaks, it contaminates, and it spreads over our river basins. So that means that we need to target this pollution hotspot at a very localized level, not only to target like the biggest place ever at the very end of the river, but making our urban areas, smaller streams and tributaries matter in our strategy to reduce the global amount of pollution. So what do we propose as a solution? We're going to use a river cleaning barrier, which is basically this kind of very smart barrier that has floating modules. Now these floating modules are just spinning passively because they're powered by the water current. So the water does the job for us, fortunately. And what it does is it stops 97.4%, according to tests from the University of Palermo, of floating and semi-submerged macro litter. There is no need for operators, and it functions autonomously for 24/7, so all day basically, and it's tailor-made to the river. So what we do when we design this technology is that we always account for the morphology and the hydrology of the river. Now, each demo site, I'm sure, has challenges. Our challenges in this project were to find an accessible place near to a bridge, because there was monitoring to make. We had less than 25 centimeters of water during dry season, while at the other end of the spectrum, we have a lot of water during runoffs and floods. Fortunately, that happens only 1-2 times per year. Then we also had to ensure safety for operators during waste net emptying operations, because the water has dangerous substances in it, and no energy to use, so all manual. And of course, it has to be easy to use for operators. So I guess you can understand the art reference for this challenge. What did we do? Basically, we reduced all the dimensions of our modules, so we made them tinier, because this reduced the weight and also increases the speed of rotation. We made them smaller also to fit low water level conditions, so it can operate throughout most of the year. And we also designed this artificial step, that's how we call it, to place it behind the barrier and basically keep throughout the year, even during dry season, the least amount of water that we needed to make it run smoothly and catch plastics. And finally, we needed it to be safe when these floodings occur. So a lifting mechanism to raise it above the water level when things start to get dangerous. Then another, let's say, design work was basically identifying a solution to empty the net for operators without getting in contact with contaminated waters. So as you can see from the pictures, the barrier is easily liftable through this handle, which can be operated by a single user. And it's also the place where waste gets stored is also easily reachable by a specific kind of ladder which has been embedded in the system. And finally, of course, all this, let's say, information, which can be very technical and difficult to understand, has been put into a specific guideline and translated into English and Albanians, and that will be part of the trainings done in collaboration with the demo site leaders to train operators for this kind of work. what we expect as next steps, we expect the system is actually ready at this very period. So we're waiting for the final green light from the Municipality of Tirana to begin the export procedure. And we're expecting to collect, on average, based on previous research and results from monitoring campaigns, about 3 tons of waste per year, approximately. But the most important thing is that we managed to reach an agreement with the Municipality of Tirana to eventually keep it beyond the scope of the remedies project. So we will have, let's say, a stable system running in Albania. And most importantly, through experience, we also got a lot of information that is useful to replicate these kind of solutions in new demo sites, not only in Spain and Morocco, but also throughout all Europe, let's say, because learning by doing is basically what we do best as innovators. So I hope that was brief enough to keep your attention focused. Thank you very much, and I'm very open for questions.
Thank you, Nicola. Thank you very much. It was very competent, clear. Yeah, let's see what the next step in Albania and then on the Po rivers too. Okay, so now we have another guest from Malta, and is Alessandro Silvestri. Please, Alessandro. And Alessandro is a managing partner of Malta Accelerate. He's a project director of Clean Accelerator Malta, and you are nurtured startup, a contributor to the growth success for over 20 years across Europe, UK, and the Balkans of startup. And you have advised ventures across industry verticals, with one of the main focuses being climate tech. And you collaborated with numerous incubators, science parks, development organizations across countries, including Cambridge Innovation Forum, OECD, French development agencies, Swiss development agency, etc., etc. Okay. So, all right. So now, your intervention is about blue tech innovation for marine pollution reduction and monitoring and prevention.
Grazie. Good afternoon, everybody. First of all, I wanted to say thank you to Plastic Free Venice for the invite. It's always a joy to be back in Venice anyway. And now, since we are running a little bit over time, I will try to be as brief and concise as possible. Now, the main message I would like to share with you all today is that yes, we have a huge problem with the health of our seaside. But the technologies that are being developed out there are absolutely fantastic. Now, talking about young talents, spin-offs from universities across Europe, horizon countries. So, the solutions to the problems we have been discussing today are out there. Now, just a very, very brief introduction about what we do for the ones that don't know us. We are an accelerator based in Malta. We started our activity supporting climate tech startups across the board. Last year, we decided to align our operations with the new strategy of the Maltese government, which recognizes blue economy as one of the priorities of the country. And Malta, as many of you know, being a very small island, overpopulated, inundated by tourists, there is huge pressure on our coastlines and the seaside surrounding the island. Now, okay, we provide standard solutions to support the growth of startups, again, climate tech, but specifically blue economy. and we closely collaborate with EIT Digital and Climate Kick. And last year we started running, we started focusing more on blue economy, and we currently run the only blue economy acceleration program, at least in the European market, which is totally tailored to the needs of the startups. And actually, I would like to say that one of the champions that came out of our demo day that we held on the 9th of May is sitting there, Algescope. It's a fantastic startup, actually based in Venice. And so, you know, we are very successful in terms of applications, outcomes, and what is the problem? We've been talking about this problem for the entire morning. Now, I would like to look at it from a more practical perspective. Only a few figures. 14 tons of plastic are dumped in the ocean every minute. Golden Bay, 30 years ago, and it used to be one of the most pristine beaches in Malta. Now there are 54, that's stats from last year, 54 plastic items per square meter. It's awful, it's terrible. Now, linking back also with what our colleague from Bradley University was mentioning about, I would like also to mention about biofouling. And now, especially how biofouling is addressed today, up to today, with manual scrapping. Manual scrapping means toxic waste, paint, microplastic being released in the seaside. So how shall we address all these issues? Solutions are out there, are under development, are being developed by fantastic young talents around Europe. Now, let's look at these three main solutions, basically. Cleaning, monitoring, and prevention. Now, I would like only to share with you a couple of case studies, very briefly. Case studies that represent solutions. Ogyre is an absolutely incredible startup which originates from Genova. They created the first global platform, blockchain-based, bringing together fishermen communities from around the world, corporates and recyclers. What they're doing is absolute, it's a dream coming true. Basically, you have large corporates that can benefit from plastic credits. Therefore, they sponsor the activity of Ogyre, who empowers coastal communities, starting from South America, Southeast Asia, Philippines, West Africa. Fishermen go out, bring back kilograms of plastic, and they are paid an agreed amount, which equals to the usual, to the average national wage, national salary, in the country where the fishermen are based. So this absolutely unique, innovative solution already allowed to recover in the past 2 years over nearly 700 tons of plastic, and growing. Ogyre just closed a deal with their equity investor a week ago for 3.5 million euro, and you will hear about their successes over the next 24 months. Now, another fantastic solution has been recently tested in the Izmir Bay, west of Turkey. Now, these scientists actually this has been designed by PhDs, so we can consider it as a university spin-off. This robot can, well, basically it's unmanned surface vessel, can go out up to a mile, can be remotely piloted with a joystick, or can his route can be planned in advance via AI and collects from the surface of the bays and marinas plastic, solid waste, plus information that are fed live back to the port authorities and municipalities. And one of the successes of from the pilot in Izmir was the first number on the left, 19 tons of plastic collected per week, which is a considerable amount, considering that it's still in the pilot phase. Now, I just mentioned that also this robot also collects information and feedback live data to the port authorities and municipalities. Planetix, it's a startup from London. They developed the first truly global ocean observatory by using satellite data, big data, and AI. So with them, we can detect pollution, measure algae bloom and forecast algae bloom issues, and assess erosion and flood risk, as well as monitoring emissions from the marine industry. They are by far the most precise on the market, and via their data also plastic removed from the ocean is 20 times higher. The last case study, this is also a startup, okay? It's funded by Italians that are based in London, but I'm trying to bring them back to Mediterranean. And basically, this is the first underwater drone developed to try to address the biofouling issue, but avoiding all the problems that we have from nowadays technology, well, from nowadays methodologies, which is manual scrapping, basically. It's much cheaper, faster, it's totally environmentally friendly, and it basically uses UV light. We are now testing it in Malta, and you will hear about them hopefully by the end of the year. And well, I try to be as concise as possible. If you have any question, please approach me during the lunch. Thank you.
Thank you, Alessandro. Thank you very much. Yeah, so we need to see that there's a new generation of people coming with new ideas and solutions because we need to be very fast in finding something sorted out. And innovation in all possible ways, also this technological and legal. And so actually there are a lot of nice ideas that pop up in my mind, but we will discuss later.
We'll talk about it later.
Okay. So we pass to the last speaker of this session is Tiana. Tiana is marine biologist, obtained a master's degree and PhD at the University of Padua. And you are a researcher affiliated with CNR. And you're involved in studying sustainable aquaculture and effects on seawater acidification marine organisms. And you focus now on analyzing the effect of environmental contaminants on marine organisms and the presence of micro and macroplastics in aquatic environments. And you're linked to the PO case study.
Yes.
Exactly, in the INSPIRE project. The floor is yours.
Thank you. So, this is for time. Good afternoon. Thank you for invitation and for the opportunity to speak about this Horizon Europe project, in particular about PO case study. So INSPIRE project is a 4-year project, which began 2 years ago, and it will end in 2027. And the aim of this project is to try to contribute to drastic reduction of the plastic weight in European rivers. So, as before, the actions of this project are basically detection, collection, and prevention, of course. And these actions are concern micro, meso, and also macroplastics. So yeah, we have 27 partners from 14 European countries and 1 Asian country. And okay. In particular, about use cases, 6 European rivers have been selected as use cases. So as you can see in Netherlands, Belgium, Portugal, Slovenia, Romania, and Italy. So today I will speak about Po case study. So we are in, this is a very important demo site because Po River is the largest river, Italian river, and it's also among the largest rivers of the Mediterranean Sea. And we are in the last part of the river path, so at the delta of the Po. And in this slide, I marked like the principal branches of the Po delta. And in this project, Inspire project is focalized in particular on Po di Gnocca or Po di Donzella branch. It's important because it's the second in terms of fresh water flow in the delta Po. As you can see, it's interested mainly by agricultural activities, and the population density is not so high, but we are at the final part of the river, so it's very important for the collection of the waste, and we are close to the Adriatic Sea. So in the Po demo case, we are focusing mainly on detection and collection. So detection will be made by, for example, cameras that will be installed on 2 bridges that are at the northern part of Po di Gnocca, so Molo Bridge, and southern part of this branch, Santa Giulia Bridge, which is a boat bridge, so it's a pontoon bridge, and it can be opened during the flood events. Cameras combined with automatic technology for the detection of the waste allow us to collect continuously data during the day hours, of course, data about type of objects, abundance, and frequency of these objects. And here we are focused on items larger than 2.5 centimeters. Also, in the entire area, we want to increase the information about the presence of the waste, also on river banks, so not only floating litter, but also litter present on river banks. And we will make it by surveys made by drones, but also by monitoring, manual monitoring, and cleanup activities. So in this slide, I put some photos about cleanup activity that we organized in March of this year. And we collect a very huge amount of waste. So yes, we have a problem here. and we know it before, and this is like we touch it with our hands. And we collect this, we organize this cleanup activity close to Santa Giulia Bridge, which is exactly the place where we want to install this hybrid solution, so technology which is able to remove floating litter. So it's called hybrid solution because it's made by two partners of the project. One is mold, so river cleaning barrier, and we speak about this before. Thank you, Nicola. So you perfectly understand how it works. And the other part is clean trash cage, so the part where the waste collected will be stored. So in this area, there is we speak about also before about challenges, environmental challenges. So also here we have challenges, and are mainly represented by big trunks that are transported in this area. So the position was chosen also because the bridge can somehow protect this technology. In this picture you can see that this bridge is open during the flood, and this is the kind of trunks and branches and things that you can find here, and we have of course to protect this technology. So lifting system was projected to protect this technology, and so the barrier is able to completely rise on the water during the flood events. So for sure, as always, we are trying to solve a problem, but we have to be sure that we are not creating other problems at environmental point of view. So we are performing, of course, also environmental impact assessment, and we are collecting data about physical, chemical, and biological parameters, and also data about the presence of microplastics in water and sediments. This is only this is an example of what we have found until here. So this is kind of baseline of microplastic concentration in this area, and this data will also go to feed the database with all the information about the microplastics presence in the environment, river environment. So we have some challenges, environmental challenges, but we have also some challenges in obtaining the permits, because it's a very long ether to have all the permits to install all new technologies. So this is the reason why probably we need some shorter ether for scientific projects and this innovative solution. That's all. Thank you for your attention.
Thank you very much. Yes, actually, we were among the beginners of this INSPIRE project when it was built up, and actually we brought some of the partners on board. Now, we could not stay in the partnership, but the region of Veneto that has endorsed the charter and the Missione Oceano Charter very recently, and will officially sign, I think, with the president of the Council of the Environment. It's up to the region, and through our friends for river cleaning, we will contribute to this project. And so that's why we're also keen to get the permission and authorization released. And in case if we can, because this is stay in the territory of our region, basically. So if we will have opportunity to discuss about this, if we can help through the region to get and release the authorization, it's very important that we implement this part of the work, and we have our friends and colleagues here. So yeah, and we are keen to see all the results and the impact of this project. Thank you very much for the presentation. Thank you. So now, because we are running out of time and we will be late, there's no any break. Maybe a few questions if there are any, or we can spare the question for later during the lunch break, okay? So I would like to ask my colleague, Manuel, to chair the session. It's the third one.
So very well. I'd like to thank, first of all, the panels of the second session. Thank you again. And I'd like to invite the next and last speakers of the day. So D.Poletto, Giuseppe Saia will be with us remotely, Carla De Caroli, thank you, and Cristina Fritelloni. Thank you again. So it's a pleasure to chair this third and final session, dedicated, of course, to the blue circular economy. This session brings together a variety of perspectives from applied research, regional experiences, but also entrepreneurship and social inclusions. So we will highlight concrete initiative and, of course, a principle of blue economy, offering scalable solutions and future pathways. So we will begin with a unique case study from Venice, the Ghost Boat program, developed under the JOINABLE project, which, of course, repossesses abandoned boat from our lagoon. So this session originally had to be covered by Giorgio Betteto and Davide. Giorgio had a family issue today, so we're very sorry he cannot join us. But Davide will do a great job, I'm sure, to replace him.
I will try to do my best.
So D.Poletto is a good friend, also a European doctorate in environmental studies and sustainable development and governance, and he served UNESCO for 13 years in the science department, so focusing on scientific cooperation, sustainable development, and Europe and Southeast Europe. So since 2019, is an active environment campaigner, co-founder and executive director of Venice Lagoon Plastic Free. As you know, a local NGO based in Venice, very active, of course, in this topic. So through the permanent Ghost Boat program, Venice Lagoon, with the small medium enterprise GIS Recycling, has catalyzed a wide range of skills, technologies, and established a pilot model that Davide is going to present shortly. Thank you, Davide, for your time, and please.
Thank you, Manuel. So I have to, okay, put it there. Okay, so we baptized this the Ghost Boat program, but I would like to go back a moment about the definition of what it is end-of-life boats, because a ghost boat is an end-of-life boat. And an end-of-life boat, for those that are used to boating and sailing, you know, is a vessel that lost their essential nautical quality. So basically, nautical qualities, structural qualities of boats, buoyancy, solidity, water tightness. The reason for this can be, because the aging, because the polymer are no more as low as like 30, 40 years ago, because they got crashed somewhere, or major events like tornado, hurricanes, you know, like Corina showed before. So for this reason, one of these reasons, they are not able to float, are unsafe. And so actually they get into the end of life time, okay? What happened is that, and we touched this argument before, that when these end-of-life boats are abandoned in nature, generally in places where a bit hidden, you know, the Lagoon of Venice has many, many islands that are not totally inhabited and a bit hidden, and there are nice place to nest the end-of-life boat and abandon them in nature, unfortunately. So we baptized them the ghost boats. Okay, ghost because the owner is not certain. Nobody knows who the owner is. And they're kept there, you know. And from Google Earth, we checked there were boats there for 15 years or more. Okay, nobody did anything. Like Irina said before, it's like you have an end-of-life car, and you just live just aside a lane and forget about, because it doesn't work anymore. It doesn't function anymore. So this is what happens in our lagoon, in the sea. And why it happens? Oh, by the way, these are source of pollution, as said before, so I don't want to repeat what's already brilliantly explained and displayed by Corina, but of course there can be also issue, safety navigation issues and a danger. And we are also a World Heritage Site. Venice is an UNESCO site. We are a Ramsar site, so we're a special place that we should really consider as an example, not just of the beauty, but also how we carry out what is necessary to protect and conserve this beauty and this heritage. Okay. So here we have the legal barriers. So there were a number of directives, speaking about European Union, of course. So the regulatory framework, the end-of-life boats, like any comprehensive directives covering this issue. And in particular, the recreational boats. They are the boats that are more frequent, commonly found. You know, the market is rising up, we saw before. We're not talking about yacht, we're talking about everybody person boat, okay? Which is very common here. So there were different directives in the past. They could have tackled this issue, but they didn't, all right? So the Waste Framework Directive, for instance, 2008, and that established very important principle related to waste management, the hierarchical waste management, does not provide arrangements for this. Okay, then we had an additional recreational craft directive that was in 2013. There would have been a very good opportunity to tackle this issue, but they failed to do it, okay? They just focused on the market, the safety and requirements for recreational boat to be sold in the European market, okay? That was very market-oriented, and that was a missed opportunity. So nothing about disposal or recycling of the end-of-life boat. Then the EU ship recycling regulation, same here, which apply to ship. So different sizes, different categories of vessels, not address the issue of the recreational boats. So we don't have a European reference, regulatory reference point to handle all of this. And then what happened is the member states are left, but you know, okay, do what you think is necessary to do, and actually, in most of the cases, they do nothing, or very little. And with some exceptions, I have to say, within the European Union, France is a very good example. They have a specific consortium defined by the producer of a boat, that they take out the boat wherever they are. Also, if not just the nature, but also you are an owner, you don't know what to do with the boat, because recycling the boat, treating the boat, I refer to this as recycling, but in most cases here, if you're lucky enough that the boat has been, in a way, treated, they just dispose in landfill or incinerate it, okay? So that's why, even here, the Regulatory Framework Directive of 2008, it's the principle related to the waste management is not implemented as it should, because we don't want to have material going to the landfill. We want to have less and less of this material to go in the landfill, because we don't want to consider there is a waste by secondary raw materials to put in the circularity of the economy. Okay, so end-of-life boats can become part of this cycle. They should, they must, always considering also the impact on the environment, as it was expressed before by the previous speakers, in terms of chemical components, contaminants, and the micro fragments coming out from these and all different pollutants the boats are a source of. So, we said there was a project, and Corina, you say there was a project of 5 million euros in Wales in order to understand how many boats are around, because nobody knows. They are broken, they are hidden places, they are sunk. It's very difficult to count them. Maybe they are end-of-life boats, they are not abandoned nature, but there are marinas, there are private owners, they have this boat pylon since years, don't want to do with that. Okay, so this material is there. So, and we posed the question to ourselves because nobody mapped the boat in Venice. Maybe for, a few attempts made by local association, but it was never a real project to survey the boat entire lagoon, which is not just the city center of Venice. When we are city center of Venice, it's a boat sunk, I think more or less, or sooner or late, the municipality or the fire brigades will take charge of it. But if we are in other islands, well, we used to go and patrol sometimes and check, and, well, forget about it. They stay there, okay? And we don't know how many there are. So I did the computation. I want to have something official, okay? So, and then we inquiry the Infrastrutture Venete, which is an institute here, public authority. And because, we have a special regulation in Venice, which is not applicable around in Italy, because the recreational boat with engine motors, equipped with motors over 10 horsepower, need to be registered, okay? So, and they give you this LV, Lagoon of Venice, identification tax, and you have to display on your boat, okay? Otherwise, you'll be fined by authority. And actually, it seems that there will be, last year, it was August last year, to get the information, 37,274 recreational boats with motor above 10 horsepower, okay? And this can be the open, classic open, cabin cruiser, inflatable boats, small boats, any sort of boats. Okay, so okay, consider that this is the amount, which is very conservative because there are many other registers that they go beyond the number, but let's keep this as all the boats around. And there are boats that have rowing boats and boats that are motor less with 10 horsepower. So considered to be conservative, so we estimate that 1% of these boats reach the end of life status each year. So we have more or less 400 end of life boats, okay, a year. This is an estimate, okay, but just to give a magnitude, and I'm going to say not all 400, but maybe there'll be a fraction of these that could be a potential source of abandonment, okay, in a natural environment. This is what we want to avoid. So, what happens is, sometimes when the state does not deliver, local authorities don't want to deliver, so citizens have the right to engage and to do something. And this is also part, as also stated in our Constitution. So say, who authorized you to do this? Of course, it's not we go there on the field and we... But actually, citizens, either single citizens or organized citizens in an association, organization, have the right to apply the subsidiarity principle to say, if you don't deliver this, our community should take charge of it. So this, the Constitution, is very important because we are legitimate to do this. So we started, and then we registered this. We got private funds, we got private donors. We didn't get any European project. We just get our own resources with fundraising. And then now we remove 37 boats and recycle them from nature. Okay, they were there. With Google Earth to say, how is possible? Nobody does anything. So at the end, you cannot expect others to do what you are able to do or you could do. Okay, so. And unfortunately, today, there is not our colleagues from GIS Recycling. GIS Recycling is one of these innovative small, medium enterprises that specialize in recycling composites. And we start with a milestone project and to make some attempts. And it looks like that we are able to treat these boats, not all of them, not all those parts, okay? The boats can be made of different things, metal, etc. So we identify a chain of value from the boat that is abandoned in nature up to a product that we can develop during the process, okay? So, and this year, in 2024, launched the operational campaign, so it will be the first operation campaign in October. We identify already a boat that's been sunk, and nobody is able to take out from the environment. and other boats that will be retrieved and treated in the facilities of GIS Recycling in Aviano, Friuli Venezia Giulia. What we thought is, okay, now we get a concept, and then we tried and found that works. And so we thought when we wrote to the JOINABLE project, the Interreg project, we thought that was a good idea maybe to share this experience from the bottom, from the civil society, in an Interreg project. And actually came out the right call for it. And that's why Daniel is here today. So, and we start talking, say, do you have the same problem in Croatia? Because you have a lot of boats there, marinas, you know, and dismantle these boats can cost more than 1,000 items per meter. You know, end-of-life boats, recreational boats are not a big yacht, because the big yacht is directive for that. Now there's no directive for that from the European Union. So the last owner is the one that has to pay the brunt, okay, for the leisure of many others before him. And he doesn't want to. Maybe he has not the money. Well, why should I buy a boat which is a later stage of his life? Maybe because I'm not that rich. Okay, there's also a question of poverty and abandonment of boats sometimes. These are social things to consider. So that's we bond with other countries, and then let me see if the other, yeah. Actually, I'll tell you just out of the record, but anyway, we developed an app for the identification under the JOINABLE project, for the identification of the end-of-life boats. We got inspiration from the French government, and now we are going to implement this app around the Southeast Europe, so in Albania, and of course in Italy, also with the Marche region, and Venice, of course, and Croatia, and what else? Well, yeah, good, yeah, several times. So basically, what we do, just for you to know, okay, I can feel that we need to act, but, and that we want to act. There is something to remove, and we should go on the field. But we know, we need to know the law. We need to know the constraints. Are we capable, able, not just because we can do it, but according to the law, are we allowed to do it? Yes and no. I mean, yes, because you should. I mean, if you say, on the other hand, you should have a chain of actors that have all the authorization to proceed from, you can identify, you can create the chain of value, but then you have all the pieces should work together and in a coordinated way. So we can coordinate this game, if you like, but each of the actors should have all the cards to play the game. So I mean all the authorization in order to remove, transport, and process, or processing until to get the final product of the boat. This is very important. So, and this is what we do, actually. We get authorization for the Interregional Directorate for Public Works for Veneto, Trentino, Alto Adige, blah, 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 so it's a long answer, under the Italian Ministry of Transport and Infrastructure. So when we are institutional authorized, we schedule the operational days. And, well, we are in Venice, so it's not, okay, we go with a truck, we take the car, and they take, no. That we have to see if the tides are okay, where the boat is located, and, you know, generally people don't want to, they put this boat in a place that's very difficult hard to get to, and then we need to have a plan. For each boat, we need to create a plan, and wait for the right tides in order to operate it. So, and all those, as I said before, we set in place a sort of joint task, all these actors, and capable to transport and to treat them. And all these you have the relevant chair. Chair is a Catalogo Europeo dei Rifiuti, okay, and the different codes, because each waste has a specific code. So you may have a authorization to remove or treat a certain waste, and others not. So you need to identify the right ones to remove, storage, transport, processing, recovery. And these are the phases that our French is supposed to present today. But basically, really summing up. So what we do, first of all, we go to we collect all these boats. They go to a pre-treatment place where basically all the metals are scrapped. All the metals and all the metallic parts are taken out, engine, whatever else. So the fiberglass is there without anything else. And the second is, so you see, and then they go to the GIS recycling with all the different recycling treatment. and basically they start shredding. And I agree with Corinne. I didn't step into the facility inside because it says plenty of powder from the fiberglass and the composite, so it's not really a health environment. But it's better to have a place which is under surveillance and is rather have these boats there and abandoned in nature, a place where they can get treatment, okay? So, and it's true, sometimes you feel like these fibers also getting into your skin. So imagine all these little, beings and get really speared by this, it's horrible. So I would try to, basically at the end, this is a sort of the processing, sorry, I'm not really an industrial person, but at the end we will mold and melt, and there's all these different phases through which basically the missing slide, but basically we get furniture of different kinds, chairs, tables, and many other things that we can use indoor or outdoor. And we start also getting some orders from enterprise that want to support this virtuous cycle, and they start ordering furniture from the end-of-life goods. Yes, and sorry, could not show you because I was relying on my colleague, but unfortunately his major force could not be here. If you go to our channel, YouTube channel, you will see all this process and phases. We have a couple documentaries uploaded. And yes, and anyway, we stay in touch for next endeavors. Thank you very much.
Very well, thank you, Davide. Thank you a lot for your nice presentation, speech, and of course, sensibilization to this topic. Now, I'd like to give the digital floor to Giuseppe Saia, who is with us, but he's in Brussels technically, so will join us remotely. Giuseppe Saia is the director of EU Know since 2010. He's a senior consultant in research innovation programs, and he specializes in sustainable mobility. He has contributed to work performed by EU Know in the WindBlue project, financed by the EMFA program of the European Commission to foster gender balance and female participation in the blue economy. So Giuseppe, thank you for being here with us today.
Thanks, good afternoon. And I want to thank, first of all, Plastic Free Venice for the opportunity they're giving to me. I also want to thank, and I'm actually replacing a colleague, Keivan Hossein, who's been in charge of the project for many of the activities we've performed, and is not here today, so I'm actually replacing him. I'm going to share some slides about the project that we ran, which is called WindBlue. Time to... I hope you can see that on the screen.
Yes, we can.
Okay. So WindBlue is a project funded by the EMFA program, so European Maritime Fisheries and Aquaculture Fund. And it's about actually the participation of women in the blue economy. Now, the background data is that so far only 29% of the workforce in the blue economy are women. And this data goes down to fairly low rates. When you think, for instance, of fairer personnel, so the question is how much and how many valuable contributions are we missing because of the exclusion of experts and professionals from the blue economy. What we have done in WindBlue, we have focused on 5 areas: the circular blue economy, aquaculture and fisheries, offshore renewable energy, coastal tourism with a sustainable angle to it, and cutting-edge technologies like, for instance, robotics. We have done several types of activities, including the actually models for gender equality plans within organizations active in the blue economy, some upskilling and coaching programs, collecting data, and also and actually sharing them through the Marina platform, which is our data repository online run by CNR. And we've also done the identification and assessment of good practices for the involvement of women in the blue economy across Europe. So this phase that we have almost completed gave a result quite interesting of 68 good practices in 14 European countries. You can see the map, and these good practices are available and will soon be available in a better graphic format on our website. So aside from covering those areas, we also looked at the challenges in terms of gender-based harassment, access to labor market, gender segregation in tasks, work-life balance, and gender perspective. Now, to give you a quick idea of the good examples we found, I'm going to quickly into 3 cases. So one is a Spanish example that comes from a company called Mariscadoras. So it is empowering women to actively participate in the blue bioeconomy, especially in times of crisis with the blue crabs. And so this is an interesting example of how women under 40 set up and run a company which is developing innovative value chains in the blue bioeconomy. I'm sure Carla De Carolis will come next, is much more qualified than me to talk about the blue crabs crisis, so she might want to talk a bit more in depth about it. Another project is, or good practice is Suez, Italy. So this is a network of women engineers who are active in several areas that connect to the blue economy, all around water, so drinking water, purification, desalinization, and so on. They launched a network. They also signed a manifesto of non-hostile words to actually deal with the issue of language inclusion. And they're also very, very careful about, the human resources investment for the well-being and mental health. Another case is AlgaeScope. That's again a startup established to identify sustainable practices that can be replicated in marine ecosystems. And it goes with some principles like it's women-led teams. They focus on sustainable product industry, and they collaborate a lot, of course, with research institutions within a gender inclusive perspective. Now, I feel I perceive clearly I'm your obstacle to lunch, so I just want to say that for those that would like to pay a visit to exotic Brussels, we ran the final conference of our project on the 26th of June. So this is about WinBlue and its findings. Our project ends at the end of July, and we hope there'll be a follow-up to it, and maybe with some of your organizations. Open for questions. Thanks a lot, and I'll give the floor back to Manuel and the other participants.
Thank you a lot, Giuseppe, for your contribution and for the great results, of course, about good practices and implementation of a project. And now I'd like to introduce to you Carla De Carolis, who is co-founder of Biochica and an expert in marine biomass valorization. Through EU projects such as WinBlue and Maelstrom and others, Biochica has developed strong collaboration focuses on turning marine waste like seafood, marine litter, and ghost boat residues into high-value biomaterials for cosmetic, agri-food, and industrial application. Thank you.
Thank you very much. And I don't want to take more time because I understand that we have very delay. And my name is Carla De Carolis, and I'm co-founder of a Italian startup, Biochica. And Biochica is is born during the middle of the COVID, after the European project, enabling projects, and in close collaboration with the other European project, and we realized that maybe in Italy we have a lot of biomass, more in particular marine biomass, as is possible to valorize it, to exploit in a huge of applications. And more in particular, our mission is to exploit, to valorize the biomass residues with the focus attention of the industrial application. Therefore, the important thing is we have novel chains. We have surrounded by different novel chains, but not all novel chains are translated in the replicated in the markets as a market solutions, and not is possible to make the scale up. In our missions of Biochica is try to focus the attention just to the scale up and the novel solution and the novel chains. More in particular, and we put and we highlighted on the specific novel chains by using the local residues, marine biomass residues. At the beginning, we started the different experimental tests by using the Adriatic crabs in close collaboration with different research and development local companies. And we've also created I can say that the small research group within our startup and focalized attention on the collection and the supply chains, because the pre-treatment collection of the suitable biomass is another key point for the solutions of the real novel chains. After that, during the last 2 years, and we focused, we specialized on our solutions in Adriatic crabs. And during the last year, we also try to make some experimental tests by using the blue crabs residues. After that, we created the network between different university departments, other small and medium enterprises, and also the startups. Because thanks to the first experimental test, we are working for the specific applications, and the novel food, functional foods, agro-industrial for the production of biopesticide, and for the cosmetic sector, of course. And more in particular, now we are also working for the development of the biomaterials. And thanks to the activities as a stakeholder of the Maelstrom project closed during the last year, and we created the small working group with the department engineering faculty, Department of Science Material of University of Trento, that was a stakeholder of the projects, and also with the partners and ISDI and Venice Plastic Free and other. And we have done some experimental tests by using the mix of marine litter, more in particular the selection of the HPDE with the chitin, and we try to have the different percentage of the material and reaching up to the 60% of organic material, chitin, that is derived from blue crab. And this one is just an example of the material extruded by our experimental test by using the 60% of the chitin. And so through this test, we can demonstrate that we can confirm that it's possible to produce the material and with different plastics and the chitin up to the 60%. However, and beyond this threshold, and increasing the organic content significantly compromises interfacial compatibility as a clear demonstrate by these images carried out by using the electron microscope, the SEM, and which highlight the poor adhesion of this one. And you can see in this slide, for example, when we overcome the threshold of the 60% of the chitin, and we have some problem with adhesions between the particle of HPDE and the chitin, and 14 reasons is not suggest to go over this percent, but in any case, through a different experimental test, we can, we can produce a different biomaterial. The important is to understand, for example, the dimension of the chitin, and it is better to use the nanochitin if compared with the chitin with the size, gross size. And at the same time, in other important conclusions that we have made through the experimental test, and important to consider, for example, the other kind of plasticizers and the compatibilizator and within the mix, because it is important to, when we want to develop the new biomaterial, and at the beginning we have to test the single material, but at the same time it's necessary to have the specific protocol for the specific biomaterial and to focus the attention of the specific uses of the biomaterial. So at last, but not least, thanks to another project, WindBlue project that was mentioned before from SAIA, our activity, research activity is in progress, and we created a new collaboration with the University of Siena, and where the next application of the mix of the chitin, chitosan, and other powder within the blue crabs is the biopackaging. At last, we are working for the new patent, and we hope that thanks to the Venice Plastic Free and ISDI and other collaboration, and we hope to close this kind of action, research action, within the next year or maybe at the end of this year. Thank you very much. If you have other questions, we don't hesitate to contact later. Okay, thank you.
Thank you, Carola. Thank you a lot for sharing the results of your studies, analysis, and good luck, of course, for the patent. And now I'd like to introduce the last speaker of the day, last but not least, Cristina Fritelloni, holds a bachelor degree in communication and works at EU Project Manager within AMAP, the Agency for Innovation in Agri-Food and Fisheries sector of Marche region. She's also worked in past at another institution managing European cooperation. Thank you, and please, the floor is yours. Grazie.
Okay, good morning to everyone. And I will be really short, since it was nice to be the last, since I had the opportunity to listen to all your speech, and really had a lot of things and a lot of food for our brain. And I'm not part, let's say, of the scientific world. I'm not a researcher, but this is for me really interesting, since I work for AMAP, which is an agency, a sectoral agency of Marche region, and we deal with agriculture and fisheries. And of course, so also the blue economy sector is included with the fisheries and aquaculture sectors. And among our aim, we also have the objective to promote a greener and more sustainable fisheries sector and to support the fishermen and the aquaculture operators to work in a more sustainable way and also at the end in a more competitive way. And we deal with many projects during the past years, and which is very important to us. And also I've been focusing over the years is the stakeholder engagement process. Since I listen to really brilliant, innovative technologies and new opportunities and new approaches, but our task is to try to close the gap between the researchers and the operators and to try to bring and to disseminate the results of your research to the sectors operators and let them to participate to join our project in the co-management and the co-decision system. And so during the years we try to implement with them a lot of different pilot testing and to improve their own sustainability, and of course we did this with the support of the researchers of the CNR, several institutes of the University of Marche region, but not only our regional university, of course, since knowledge is relevant and we should gain knowledge from all the institute and all their research possibilities. And another part is very relevant for us is to raise awareness on citizens and on consumers and promote networking and aggregation among blue economy operators. And you can say this we have a long history of cooperation, and for us, European territorial cooperation projects are also important since from the other side, we are also very close to the policymakers, since we are a regional agency. And we support and we try, let's say, to improve the policies related to agriculture and to fisheries, and also so to the blue economy. And you see, we are now in this new programming period, and we have 2 projects now, which is joinable, of course. We are here also for that, and the 3 fishing project. But we built on a lot of projects in the past programming period, and in all these projects we always try to involve operators and small and medium enterprises and to make them part of our pilot testing. And I just share some good practices. These are some protocols for more sustainable fisheries and biodiversity improvement. This was done with the CNR IRBIM that once was joined with the Institute in Venice, ISMAR. And you can see this was like a kind of a modified traps for restocking purposes. You can see all the cuttlefish egg in the trap nurseries, and it was a basket trap for Nassarius mutabilis fishing with increased selectivities. And you can see some practices for the fishermen, just avoiding the cleaning of fishing gears. You can see how many cuttlefish eggs anchored to the fishing gears. Other good practices is some action to reduce the ecological impact of mussel farms. We test the use of rope nets, and in the other project we test also other bio-based materials instead of plastic one, which is great issue of pollution also, since we have several mussel farms in the regions. And other projects were instead focusing on innovative processing technologies of food, like, for example, HPP, so high pressure processing, and we to try to extend the shelf life of the fish products, and also use, let's say, all the fish, so avoid waste. In this case, we test some fish burgers. and this was made in cooperation with the Croatian partners. And this was another project with the lead partner was the University of Bologna, and the project developed an underwater drone which was called Balzi, and it was equipped with a lot of sensors and instruments, and it was a complete non-invasive mean to assess the environmental biodiversity and also the fish stock population. And so we try to involve also environmental research companies, which are a relevant pillars of the blue economy circle. And this is the last, the other project that is in progress now, and it's always an Italy-Croatia project, and the lead partner is the University of Bologna. And we are now creating an hybrid engine for the fishing boat under 12 meters. So we are talking about small-scale fishery, which is like a priority of European Union, and also one of the most sustainable fishing in all the European Union. And we try to address the problems and the challenges they face. And we are trying to create this hybrid engine on two boats. One is a catamaran, which is used for fish farming activities. Another is a research vessel of the Institute of Fisheries based in the Splits. And as a public institution, we are contributing, not with the technical part, engineers are doing that, but we are analyzing the behavior of the fishermen. So to understand if this hybrid engine will be accepted and if it's feasible and if it's convenient, also from an economic and social point of view. And of course, this will bring, first of all, to a reduction of CO2 emission and the carbon footprint, but should also optimize the operation of the fishermen, the aquaculture operators, and should improve their competitiveness and reduce the costs they have, especially, of course, the fuel cost. And we are also partner of the JOINABLE project, which will and we will tackle this marine litter pollution through the different project actions. And of course, we are going to use the app we are testing these days with the fishermen for the identification of the ghost boat, and as well with the students. And we also will involve the Istituto Montani. You listened to Teresa before. And also we will try to involve the policymakers to improve the policies related to the blue circular economy, and also to push for some networking with some European networks like the Plastic Smart Cities. And the pilot action, we will capitalize the work you just listened before from Carla and other partners, and we would like to try to blend some, with the support of the researchers and other partners, some bio-based material from the crabs or from other fish waste with other polymers, and we'll try to, at the end, the objective is to furnish with some urban furniture and support some of the municipality of Marche region that also will join the project. And so we hope that we can, let's say, give a push and involve both the fishermen and the other enterprises, and to try to let's say, to contribute to the setting up of this value chain of the blue circular economy, also at a regional level. And if you have any question, I think we are ready for lunch. We can discuss during the lunch. And thank you very much. And thank you.
Thank you, Christina, for your contribution. Very interesting, the part related to the behavior of fishermen. Of course, congratulations for the cooperation with institutions. And now, let's see if there are questions. No questions? Very well. No, I'm joking, of course. We are available anytime to all your questions, but also during lunch. So you can, of course, use that time in a very nice way. And probably we are ready for the final remarks, so closing remarks with our speakers. So if I can just add one word from my side, we really share interesting, of course, project ideas, ambitions on, of course, a blue circular economy, of course, to foster innovation and efficiency, but probably it's not just this, it's much more, it's about embracing a sustainable mindset, because, of course, if we have the right mindset, we can really preserve the future of the oceans, community, and, of course, our needs and our companies, of course. So thank you for being here today. I'd really like to leave the last word to Davide. Thanks.
Very short. Thank you very much, Manuel. And it was a very nice experience this year, I have to say. And all the people that contributed, and Gerardo Toso, the Deputy Director of Venice Plastic Free, and Mariam Tawfiq, our new communication officer. Of course, I have not mentioned our president. Where is the president? Here, President Marina Doria, and Lorle Novelle and Anna Sherman, our interns here, and Manuel. Without Manuel, it's impossible. Manuel is really a miracle man, and he is able to fix everything. With the capacity, detail, and memory management, I never reached my life. And then all these your friends of the Salone Nautico Venice and all the technicians here, and Silvia Ghedin, Dario Silvia, Piozzo Roberta, Alessio Brolati, and all the partners and all the contributors that came from here around, but also from UK and from Malta and from Croatia, and all the partners, all these projects, and those are not part of the project that will be part in the future projects. So thank you very much to all of you and our friends for CNR too. Thank you. Yes, we have a lunch. It is not. It's a refectory, so but a light lunch together. So you're all invited, and we can spend some time together. Right? All right. Thank you.